Hello everyone, thank you for joining me today. My name is Priya Shah and I am an associate professor in residency at the University of Connecticut in United States. I'm delighted to share with you two of our projects that emerged from a simple question. How can we prepare chemistry students not just to pass exams but to thrive in diverse careers? In our organic chemistry courses at the University of Connecticut or UConn, we often encounter students with tunnel vision. Many are pre-med or pre-pharmacy majors who believe that a high grade equals career success. What they frequently lack is the awareness of the breadth of career opportunities available to them and crucially the professional skills that the employers actually seek. Today, I want to share how we address this gap by weaving together service learning and career readiness competencies into a rigorous organic chemistry course and what our students told us about their growth. Before I describe our projects, let me clarify what we mean by service learning because it's distinct from other forms of community engagement. Service learning is an educational approach that combines academic coursework with meaningful community service, fostering reciprocal learning between students and community partners. Unlike traditional outreach or internships, service learning is characterized by its integration of structured reflection and direct engagement. The key word is reciprocal. Students not only serve, but they also learn by the communities that they work with. The community partners' need drive the work, and the students' learning is intentionally connected back to the course objective. This is crucial because it means that service learning is not charity. It's a partnership rooted in mutual benefit and respect. Let me start with the context. Organic chemistry at University of Connecticut is mostly taken by second-year undergraduates pursuing pre-professional or graduate pathways in medicine, dentistry, pharmacy, or related fields. These students are intelligent, motivated, and anxious about their grades, but they often see organic chemistry in isolation, memorizing mechanisms, solving problems on the exams, and then just moving on. So, what's missing? I believe it is the connection to purpose, connection to the real world impact, and connection to the idea that chemistry skills translate directly into professional competencies. To bridge this gap, we designed a semester long service learning project in partnership with UConn's Student Health and Wellness, or Shaw, our community partner. My organic chemistry lab students participated in this service learning project. This wasn't a hypothetical community service. It addressed an urgent, timely need. With rapid policy changes legalizing cannabis in many United States, there was a critical gap. Students and broader public lacked clear, science-based education on responsible use of cannabis. Shaw's mission is to promote optimal well-being of all UConn students. They identified an urgent need for educational material on cannabis chemistry and health. Materials grounded in real chemistry, not politics or stigma. So, what did our students do? Cannabis contains over 100 different cannabinoids, compounds with distinct chemical structures and effects. Two key examples are tetrahydrocannabinol or THC and cannabidiol or CBD. Both share similar chemical frameworks around benzene ring and a terpene side chain. But THC has an additional cyclic ring that CBD lacks. This seemingly small structural difference leads to vastly different pharmacological effects. THC's extra ring is directly associated with psychoactive properties, while CBD does not produce the same intoxicating effects. Rather than only solving textbook problems about these molecules, our students created educational materials, brochures, posters, and visual guides explaining cannabis chemistry and its responsible use. They consulted with our community partner, Shaw, early in the semester, conducted self directed research, and presented their work in a public poster session at the end of the term. And here's the payoff. The brochures that our students created are now being used by Shaw across all UConn campuses to educate thousands of students. Now let's talk about the second project that we also integrated in our organic chemistry course. Another approach that we adapted was to embed career readiness competencies throughout the course. Let me explain why this matters to a chemistry educator. The National Association of Colleges and Employers, or NACE, identified 8 core competencies that our employers consistently seek in college graduates, regardless of their field. These aren't just soft skills, they are professional practices that our students must develop to be competitive. The 8 competencies are career and self development, communication, critical thinking, equity and inclusion, leadership, professionalism, teamwork, and technology. Now, you might ask, how do these fit in organic chemistry? And my answer is everywhere. Chemistry courses are perfect laboratories for building these competencies because the work is inherently collaborative, rigorous, and consecutive. So, how did we embed NACE in our course? We took a structured approach. First, at the start of the semester, students completed a pre-course career readiness survey and a NACE self-assessment, asking them to rate their confidence and capability across all 8 competencies on a scale of 1 to 4. Second, students engaged with Decision and Destination module designed by our Yukon Center for Career Development. This module guides students through self-reflection on their strengths, values, and career interest, helping them see connections between their major and potential pathways. Third, we invited a guest speaker, Dr. Vincent Prestito, a research scientist from Pfizer and a Yukon alumni. He shared his career journey, the skills that mattered the most, and how organic chemistry's knowledge opened unexpected doors for him. Hearing from a real world chemist working in an industry changed how students viewed the course. Fourth, students completed an in class career presentation where they had to articulate how organic chemistry connects to their major or intended career path, which NACE competencies they developed during the course, and how would they communicate this to their employers. Finally, at the end of the semester, they retook the NACE assessment so we could measure their growth. At the start of the semester, I was thinking that my course will have the highest impact on critical thinking abilities of my students. But to my surprise, the following NACE competencies had the largest gain: career and self-development. Students had a gain of 0.99 on a scale of 1 through 4. This was our largest single gain. Students became more proactive and confident in initiating professional connections. Second, oral communication. The growth was by zero point 0.9. Students reported greater confidence presenting their work and articulating technical ideas to diverse audience. Leadership saw a gain of zero point 0.8 points. Students who started the course feeling timid became visible voices in group discussions and presentations. Critical thinking saw a growth of 0.66. This is particularly meaningful as organic chemistry requires students to synthesize information, evaluate mechanisms, and justify their reasoning. Exactly the analytical thinking employers demand. Beyond these headlining numbers, students also reported higher confidence linking coursework to skills, improved ability to translate that work to resumes and job application, and greater awareness of NACE competencies and career center. At the start of the semester, only 57% of our students knew what NACE competencies were, and by the end, 100% knew. Similarly, awareness of the career center location jumped from 53 to 100%, and the actual use of career center website also doubled. What strikes me is that most of the students did not resent the career components. They embraced it. They and I believe that happened because they saw chemistry as a pathway and not just as a hurdle. Here's what this project demonstrated. Integrating career readiness or service learning into STEM does not require overcomplication. It doesn't mean abandoning rigor. It means being intentional about helping students see why they are learning and who they are becoming as scientists or professionals. If you are thinking about integrating career readiness or service learning in your own courses, here's what I would emphasize. Start with a real partner and a real need. Shaw had a genuine need and the students felt it. Be explicit about competencies. Don't assume that the students will intuitively connect lab work with professional skills. Name them, reflect on them, assess them. Invite voices from the industry. A 30-minute visit from a working chemist in the real world can shift student perspective more than a semester's long of lectures. Create space for student voice. The in-class presentation and reflection survey weren't just data collection tools. They were pedagogically powerful. Students needed to articulate their growth. Maintain discipline rigor. This isn't dilution, it's deepening. Chemistry students who can explain why a mechanism matters and who cares about the reactivity are better chemists. The vision of new perspective in science education resonates deeply with what we are doing. Too often we compartmentalize. Chemistry lives here, careers live there, real world impact happens somewhere else. But our students live in an integrated world. They need to see themselves as future professionals and not just test takers. When we weave service, reflection, and career awareness into our rigorous coursework, we don't lower the bar, we raise it. We ask students to not only know chemistry, but to use it responsibly and communicate its value. That's the perspective I'm excited about. And I hope it resonates with you as you think about your own classrooms. Thank you.